Hi, my name is Matthew Mullis, and this is my Physics 2212 Lab Report 3 on the magnetic field of a bar magnet. So, the purpose of this lab was both to create a physical representation of magnetic fields, one that we could witness in live time, as well as to help to model and better increase the understanding for like my lab group of the relationship between distance and magnetic field. And so, the results of this lab, where we found that the magnet had an in value of negative 2.173, as well as mu was equal to 10.579. So some key concepts we used here was the Biot-Savart law, as well as the magnetic field of a dipole on an axis, and the superposition with magnetic fields. And down below are some different magnetic field formulas based on these concepts that we used. So some assumptions and accountment for possible error. The system here was the magnetometer of the iPhone that we used for recording, as well as the surroundings were the magnet that was being used near the magnetometer, as well as everything else on the Earth. Our assumptions were that only the external magnetic force was from the magnet. However, some possible errors could be miscalculations or inaccuracies in data recording, as well as the influence of surrounding objects, such as like our phones in our pockets or other things we didn't account for. And the way this lab worked is we had the phone, we figured out where the magnemometer was in it, and then we found different values of like the magnetic field at certain distance and different magnetic field strengths at different distances by moving a magnet along a parallel axis to the phone, which we had a ruler underneath. So this was the data we found. Here we can see our graph, and our n value is the slope of the graph, which was negative 2.2173. And we can see all the different data for that me and my lab group found, my group being myself, Kylie, Kate, Emily, and Chandler. So then the calculations that I did in order to find our mu value. So using that formula, I set the magnetic field, which is equal to KRN, K times R to the power of N, equal to the magnetic field on an axis, which was mu naught over 4 pi times the quant times 2 mu over R cubed. And here we know that mu over 4 pi is a constant, which equals to 1 times 10 to the negative 7th. So we set these equal to each other. Then we use the formula of L ln of B or of the magnetic field equals ln of K plus N times ln of R. So then plugging in the different values from our data shown here, I then found that ln of K was equal to negative 13.926. And then from there, we said that K equals e to the power of negative 13.976, which is about equal to 8.594 times 10 to the negative 7th. And then using R equals 3, we found that mu equals 10.579. So this was the code that I used in order to program the lab and plug in that mu value, the magnitude of it, as well as other different things in different scales and distances, ultimately resulted in the following results, which was this, showing a magnetic field perpendicular of negative 2.1 times e to the negative fifth at a distance of 0.424264, and the magnetic field at 45 degrees at distance d being 6.926 e to the negative 6 in the x direction and 2.078 times 10 to the negative fifth in the y direction and 0 in the z directions. And the magnetic field would be at 45 degrees at distance d equal to 2.19031 times 10 to the negative fifth, and we used a distance of 0.369 meters here. So our conclusions, so these were different problems to say if these were true or false given the experience. So when the magnetometer is far away from the magnet, measures near zero magnetic field in this x direction, that's true. But the next two statements of as the magnetometer is closer to the magnet, the measured x to the field decreases, that was false as the field increased, as well as the position of the magnetometer has no effect on the measured x component of the magnetic field, that was also false. But as the magnetic field moved closer to the magnetic field increased, that was true. So what if we hadn't oriented our experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle? This would have significantly changed our results, as we would have, like, it wouldn't be properly orientated and we'd have different values in different things. And if we were to stick two identical magnets in together and run it again, I would expect that we would have a stronger magnetic field, as there's now two magnets. Thank you for watching and having a great day.